All right, so today we get to talk about surface area of pyramids, spheres, and cones. Actually, we're going to focus in on pyramids today, and we'll do the spheres and cones next time. So a pyramid is different than a prism, right? What do you call this? Prism. And so if it is a prism, what does it have?
Two parallel bases.
Two parallel bases. So we say the hexagons, right? The hexagons. And this does not have two bases. How many bases does this have?
One.
And an opposite vertex. And so this is called a pyramid. If it was a cone, it would look curved, right? And the bases of cones are always circles. We're going to put that off until tomorrow. Today we're talking pyramids. Always an opposite vertex with one base. And what shape are these lateral surfaces?
Triangles.
Triangles, all of them. Okay, so let's draw this. This pyramid is, as all pyramids are, named for their bases. So you look down at that base that is opposite the vertex and you identify the shape of it. And so what shape is this base?
Square.
Maybe a square. I don't really have enough information to know if it's a square, so we could say it's a rectangular pyramid. So we name it by the base. If you want help drawing it, okay, well I'm going to do it again one more time for the video. We have a rectangular base. Whoops, I'm out of calibration. Just a second, let me calibrate. Okay, try it again. Here we have a rectangular base. We can't see all sides of it because it is three-dimensional. So we are able to kind of hide the sides that way. And then we have a vertex opposite. And so I'm going to just stick a vertex up there. And I can see this front edge, and this front edge, and this side edge. But I can't see this edge, it's kind of behind the figure. So there are many ways we could twist and turn it, but there's one way you could draw it. Okay, notice we have two different kinds of heights in pyramids. This is so critical. One height is the height from the vertex straight down to perpendicular to the base. So that's what this little, it almost looks like a chair, but that's a right angle. We have a perpendicular distance from the vertex to the base. And then we have this other height out here, which is actually laying on the side of the pyramid, which we said the sides are always triangles, right? So we have what's called the slant height. It is actually the height of one of the side triangles, slant height. And we use a cursive L, lowercase l, to show slant height. Okay, so that's going to be really important when we're talking surface area. So let's make a note of it. Pyramid height must be perpendicular distance from base to vertex. And slant height is perpendicular height of the lateral triangles. So we're going to find the surface area of a pyramid today. And so before we do, we're going to make a net of one of these rectangular pyramids. And so I have cut one out. This is a little different than the models you're cutting out because the models have tabs on them so you could fold them and glue it together, right? This is just showing you a net without any tabs on it. So I could assemble this pyramid, kind of hard to do without tabs, by forming all four triangles to the base and bringing them all together at a vertex. So it is a pyramid, but when we pull it apart, really how many triangles do we have?
4.
So that's based on the fact that the base is what shape?
Square.
Or a rectangle. I'm not sure if it's a square, but it has 4 sides, right? If I have a pyramid like this one, which has a base with 6 sides, it's a hexagon, how many triangles are formed there? 6. Okay, so that base is what tells us how many triangles are formed in a pyramid. So let's go ahead and draw a picture of the rectangular pyramid as a net. Okay, so the way that my net was formed was, I think we had kind of 4 triangles all in a row. 1, 2, 3, and 4. And there you go. We could just kind of turn them each to one side of that base and bring all their vertices up here together, and we would have that pyramid. Another way that Emily suggested we do it is have our base and then have, you know, a triangle shown coming off each side of that base. All these triangles would have the same height, given what we're doing today. So the pyramid formula is somewhat like the prism formula, but our prisms had 2 bases. And pyramids have how many bases? 1. So look at what we're going to do. We're going to add 1 base area. Here it is, 1 base area. And then we're going to walk around, just as we see here. We're going to take this base, and this base, and this base, and this base, and then find the height of each of these triangles. How many triangle areas are we finding here? 4. So because of the base type, we are finding 4 triangle areas here. And we found it by walking around our base, which is called what? A perimeter, and then multiplying by the triangles. All have the same height. Oh, what do we have to do to it though, because they are triangles? If we do base times height, what do we have to do? Divide by 2. Okay? And that we have to do for all pyramids, because all pyramids have lateral triangles. Okay? So here's our little formula. You can box it up. Pyramids have 1 base area. You need to leave it a capital because each pyramid has different kind of base, right? And then perimeter of your base times the slant height. Those are your little triangle heights out there, right? Divided by 2. And you might want to include what L and P mean inside your rule box. Okay, let's find the surface areas of these figures here. Number 1, it is Aiden. Tell us what type of a pyramid we have here. Yes. It is rectangular, and we can actually be more specific because they gave us the information about the lengths of the sides. So look at that base. We could even call it a square. So this is a square pyramid. The base has all sides of 8. So we can call it a square. So once again, we start with the formula for the area of a pyramid. It has 1 base area plus, we're going to walk around the base, perimeter of the base, times the slant height. Now those are triangles, so when I take each of those, I will have to divide by 2 to get all those triangles. Okay? And so now the base area in this case, you know, sometimes, who remembers, we talked about this, when the base, when the parallelogram is a square, there's a different variable that is sometimes used. Remember what it is? We could say BH, but because they're both the same and it's a square, often S squared is used for squares. Okay? Are you okay with that? 1 side squared. I want to throw that in here because I don't want you to come across it in an assignment and say, well, what is that? I never learned S squared. But it's because this is a square base. Okay? So S squared plus PL over 2. And now substitute the values. And we have feet in all directions, so I'm going to make a note that our answer is feet squared. And Alex, do you want to tell us how to substitute? 8 squared plus, what's the perimeter of the base? 8 times 4, right? Walk around. 32, and then the slant height for each of the triangles is 12, so 32 times 12 over 2. We need to do this multiplication before we add, right? PEMDAS says all multiplication before addition. So can we do a little reducing here? Yeah, how do you want to reduce in this parentheses column?
By 2 by
2 into
12.
Into 12? Okay, it could go into either one, right? So we have 64 plus 32 times 6. He's doing this right here. And now 32 times 6 is simply 30 times 6, which is what? 180 plus 2 times 6, which is 12. 180 plus 12 is
196. I mean, 192.
192. And now we can add horizontally, we can kind of practice that. 4 plus 2 is,
6.
and 6 plus 9 is,
15.
so carry 1 up here, and we have 256.
Feet squared.
Excellent. Okay, so put away the calculators and try to do these calculations as much as you can, right? Now, number 2 is a little easier, but it might seem confusing. What did they give us here in 2? Gabe? They gave us the triangle, not, what do you mean when you say that? They gave us capital B. What is capital B? It's not just base, it's base. Capital B stands for base area. They gave us the whole entire base area. We don't have to find it. But you do need to know what a capital B is, see? Okay, so is this still a pyramid?
Yes.
So we'll start with that. We have the surface area equals base area plus the perimeter of the base slant height over 2. And now we are given the entire base area, which is such a beautiful gift. Yay. And now we simply need to find the lateral, non-base areas, right? So Gabe, tell us how to fill that in. Do you know the perimeter of the base? Were we given the third side of that triangle?
But use hypotenuse.
Do we know it's a right triangle?
Yeah, it actually is, because you can see on the bottom. Bottom right.
Well, this here is,
No, on the, next to the 12 on the right, you can see it. You can see it on the right triangle.
you know what? They didn't tell us that it is a right triangle. I don't see any sign that it is a right triangle. So what are we going to have to do to find that third side? This is actually more challenging than I thought. Do we know the area of that triangle on the bottom there? Don't we have the area, 62.4? 62.4 is the area. How do we find area of a triangle? BH over 2. Now remember, any side of a triangle can be the base, as long as you have the perpendicular height. We are trying to find, well, we're trying to find the third side, aren't we?
I got 60 still.
You use 12 for your third, let me pause the video
Yeah,
while we think about this. Okay, so they haven't really provided you with enough information here, but let me tell you, this is an equilateral triangle. So let me add that. You could go ahead and add that into your picture too. A little hash mark, a little tally mark on each one of those tells us each side is equal. So now we're going to know that the perimeter, as you said, is 36. And somebody said already we multiply by 10 and divide by 2. Okay? And you've already given me this, so you can work it out at home if you're at home. But they gave me this already. So who can give us our final answer to the 10th place then? Stuart.
232.4 inches squared.
Good job. Okay. If they had told us that base was a right triangle somewhere, we could have used that to find a different, a missing side. But they didn't tell us that, so that was not very nice. Okay, before you go into your assignment, we've already talked today about surface area of a sphere, but we need to add it in here to this lesson. Okay, so we know a sphere is a perfect ball, right? A perfect ball. And so here is a little mini Little League ball that was taken apart, right? And when you take it apart and you look at this, if you were to estimate how many circles it takes to provide the surface area of a sphere, you would say how many circles? 4. And that's exactly our formula. 4 pi r squared. 4 circles. Okay, so we have 4 circles forming the surface area of a sphere. Now, if I cut 4 circles out of paper and try to have that go to a perfect sphere, will it work?
No.
No, but actually, in reality, if you were able to stretch it and mold it into the little grooves and stuff, it would give you the proper surface area of the sphere. Okay? So it's kind of interesting. What? All you have to do is take an actual sphere and lay it out flat, right? And then cut it all apart, and you'll find that the actual radius of the sphere is all you need to find the 4 circles. And that area matches up. Now, if you want extra credit on your 3D models, you can find a template for a sphere that is done with paper. And it requires a lot of cutting and maneuvering to put it together, because each side, depending on the template you get, is going to be like a multi-sided polygon. And in many of the templates, more than one type of polygon is used. So you could go online and just Google sphere template origami or something, and I each year have about 4 or 5 students who do that for extra credit on your 3D figures. And you can add it to your set, okay? So let's find this surface area, and then you're on your own. Draw yourself an image of a sphere. If you want help with that, that's usually we start with a circle, and then you're trying to show, like you would with a jack-o'-lantern or something, the behind side, you know, what's behind it and what's toward the front. Sometimes people, you can have all of these kind of meet close together like a basketball would or whatever. It's hard to draw on a 2-dimensional piece of paper. But the surface area is just 4 circles. Now, did they give us the radius, or do we need to do something here? Spencer?
It gives it a diameter.
So what are you going to do?
Half.
And you get?
3.5.
I'm not sure, but they drew the line completely across, so we're thinking it's a diameter. Okay, you could always ask for clarification, but that's what it looks like since they drew the line completely across. If they had drawn just from the center point to the edge, you would think it's a radius. So now we just solve this. And 3.5 squared, who has that? 3.5 squared? Colin?
Oh, I have 4 times 3.4.
Are you saying 3.5 squared is 3.4?
No, I've got 3.4 times 4.
Lauren, do you have 3.5 squared? We found 49 pi inches squared. I'm leaving this in terms of pi. If the instructions say you need to round it to the tenths, then of course you're going to use pi. If the instructions say you can leave it in terms of pi, this is how you leave it in terms of pi. Just leave it sitting right there. Okay?
Do you have to
There
leave
you
it in
go.
terms of